typical phone.
And I emailed you the packet. It's like for my test that's coming up that I wanted to work on for a bit, if that works.
Okay, yep.
So I took pictures and emailed it to you.
Guys, check my emails. I got it.
And then like
which one
the first
to start with?
Well, the first picture there, I think I'm good on that page. So like the last 3 pictures, so we can start on either one.
I'll start on the second one.
Okay.
Hold on a second. This is one of those where I have to download it in order to be able to zoom on it. I need to download it. Now I can zoom in so that I can make it a little bigger. And so it looks like you're beyond proofs. I'll bet you're happy.
Yes.
Or are you one of those rare individuals that liked proofs?
I mean, I liked algebra a lot, so I don't like geometry very much.
Well, trust me, it'll get easier once you get beyond proofs.
Okay.
This stuff here is the real geometry. Why they start everybody off on proofs, I have no idea. You want to demoralize somebody, do that. It would be like me teaching you how to ski by dropping you on an expert slope and say, here, get yourself down the mountain. As opposed to starting you on easy slopes, and then once you master that, go to medium slopes and then hard slopes. But math doesn't use that logic. And it's not just geometry. Virtually every math starts you off with one of the most difficult parts of the semester. Whether it's geometry or algebra 2 or trig or calculus, doesn't matter. They all do it. So yeah. Let's look at this first one. What can I say? What kind of an equation? In other words, we're in the part of geometry now where you're going to use a lot of algebra also.
Mm-hmm.
So all of these problems, you have to come up with an equation and solve it. So what's the equation that I can write?
Well, we know there's a 90-degree angle, so would we add that in our equation too?
Well, let's put it together. X plus 4x has to be equal to 90 degrees.
Okay.
In other words, because that's 90 degrees, then you also know that that is 90 degrees.
Yes.
Okay? In other words, when you have perpendicular lines, all 4 angles are 90 degrees. So that's what allows us to write that equation. And now simplify that and solve for x.
Okay.
Do it verbally if you would, so I can write it.
Okay, so you add the 2x, you'd have 5x equals 90.
Okay, next one.
And then you divide 5x by 5 and 90 by 5, and you get x equals 18.
Perfect. Okay, give me an equation for the second one.
So that would be the answer for the first one?
Yes.
Okay, cool.
Well, I'm sorry, does it want both angles or does it just want you to solve for x? It says just calculate the value of the variable.
Yeah, so it's probably just that one.
Yeah, if it said give me both angles, well then that one's 18, but this one's 4 times 18, which is 72. So it kind of depends on what the instructions say. In this case, they really just want us to solve for x. So what equation can I write here?
Why don't you just set them equal to each other? Or would you do x plus 2?
They're a linear pair, right?
Mm-hmm.
In other words, a linear pair you get whenever you have a straight line that's intersected by another line, like that, another straight line. And what that means is that both of those add to 180. They're supplementary. And that's what supplementary means. Supplementary means they add to 180. Complementary means they add to 90. In the previous problem, those 2 angles were complementary. So that's why we could add them and say it's equal to 90. And in this case, they're going to add to 180. So give me an equation where that adds to 180.
X plus 25 plus 2x plus 20 equals 180.
Now solve that.
Okay. So 2x plus x is 3x. 25 plus 20 is 45 equals 180. Subtract your 45 from your 180. So 3x equals 135. Divide the 3x by 3 and the 135 by 3, and you get 45.
45. You're right. I was doing it in my head and I was wrong. Thank you.
Yes.
Okay, let's do lower left. This time just read line for line. You don't have to tell me what you're doing. I can tell you know what you're doing on algebra. So let's see. First of all, which one can I solve? I got to solve for x and y. Can I solve for y first?
No.
Okay, which one can I solve for first?
X.
Okay, give me the equation.
Would you do 5x plus 7x plus 4 equals 180?
That's 17x plus 4 equals 180, correct? Keep going.
Oh, sorry, 17.
Just read the next line.
Okay, and then 17 plus 5, 22x plus 4 equals 180. Subtract your 4. 180, or sorry, 22x equals 176. Divide your 22, and then you'll get x equals 8.
Now give me an equation that lets me solve for y.
Would you just plug in the 8 to the original equation?
Well, what you know is these two are vertical angles, correct?
Yes.
Whenever you have two straight lines cross one another, you create vertical angles that are equal. So what I can say is that y equals 5x. Okay?
So then you just do.
Now you do exactly what you said. Plug it in,
Okay.
and you get 5 times 8. That's what y is. So you've solved for both variables. Okay.
So y equals 40. Okay, perfect.
Okay, now let's do the fourth one, lower right. Excuse me.
Okay.
And you kind of have to figure out, wow, how are you going to solve this?
Oh yeah, because you have y.
Well, you got y in this one, you got y in that one, and you have only x down there.
Mm-hmm. Would you just do the 8x?
I can't do it with just one equation. I'm going to need two equations.
Okay.
And here's why I can't. In other words, I know that 8x plus 4x plus 7y is equal to 180. And I also know, but I can't solve that. In other words, when you only have one equation and two variables, you never can solve it. There are an infinite number of solutions.
Yes.
But if I have a second equation where I can say 8x is equal to what?
180.
No?
Oh, sorry, 90.
No, vertical angle. We don't really know those are 90-degree angles. They didn't put a little square. If they don't put a little square, they're probably not 90 degrees. But we've got two vertical angles here that have to be equal to one another. So 8x has to equal 2x plus 4y.
Okay.
Okay.
So then you just would.
Well, and then simplify that. So you get 6x equals 4y. Solve that for either x or y. And once I solve this, in other words, x is going to be 2/3 y, right? Or y is going to be 3/2 x. Well, it's actually a little easier if we solve for y, and you'll see why. Now we can use substitution. In other words, we have one variable solved in terms of the other variable. So I go back to this first equation. In other words, what we had here was a system of equations that we were trying to solve. And you need both equations in order to be able to solve for two variables. Well, we had two different equations. So I'm going to solve them by using substitution. And wherever I see y, I'm going to write 3/2 x. Okay? So
Okay.
I've got 8x plus 4x plus what? Give me the rest.
Plus 3
Hold on.
half.
Just fill it in initially. In other words, don't do anything with the 7. And now we see y, and I'm going to fill in 3/2 x for y. That's the way I would like you to see you do these. In other words, never try to do this math at once.
Okay.
You're much less likely to make mistakes if you do it one row at a time and don't try to do two math steps at one time in your head. Notice I didn't even combine the 8x and 4x. Okay?
Mm-hmm.
Even though most people would, and they would have written 12x. That's pretty straightforward. And what's the rest of it?
12x plus 7 in parentheses.
Now you can multiply the 7 times the 3/2.
Okay, so
it's okay to do two steps where one is completely different than the rest of it. So I can do two steps now because I'm not doing two steps in my head. I'm doing the second step on paper. So what's 7 times 3/2?
21 over 2.
X equals 180. Now what do I have to do?
Add the two x's together.
Good. How do we do that?
So why don't you just do, well...
Let me give you a piece of advice on solving equations. When I have a denominator in an equation, I hate it. Fractions just complicate things. Let's get rid of the denominator. Well, what's a really easy first step to get rid of that 2?
Divide the 12 by 2.
Multiply both sides of the equation by 2.
Okay.
Notice why that gets rid of that 2, because it's going to cancel with it. But
right.
I have to multiply every term by 2. Well, that turns it into 24x plus 21x equals 360. Now, even though these are bigger numbers, it's a much easier equation. Would you agree?
Yes.
Just because I don't have any denominators, which means I don't have fractions. Well, that's 45x equals 360. And now your calculator should show you that x is
8.
Now, once you've solved for x, you go to the simplest equation you have and plug in 8 for x. And that'll tell you what y is.
Okay.
So 3/2 times 8, our answer that we know x is equal to y. And don't do this 24 divided by 2. Divide top and bottom by 2 first. Turns that into a 4, and you got y equal 12.
Okay.
When you simplify it first, just reduces the size of the numbers you're dealing with, which is always a good thing for accuracy's sake.
Okay.
Notice the way I did it, 8 was the biggest number I had to deal with. Whereas if I multiply the numerators, I got 24 divided by 2. And that might be easy to do, easy enough to do, it is. But that's kind of the secret to simplifying this arithmetic, is making sure you simplify before you multiply. Whether you're dealing with a whole number times a fraction, or even if you're dealing with two fractions. Like if I was multiplying 7/5 times 5/7, I'm never multiplying that out and getting 35 over 35. I'm always doing this. That turns into 1. That turns into 1. Those turns into 1. So that's the answer without doing any math at all. Okay. Let's go to these. This is the geometry I love. Most of proofs. I hate it. Actually, the way geometry does it is perfect for me because usually a student doesn't come until after a month or two has gone by. And that's the month or two that they do proofs. So not always working out like that, but this is what I consider the real geometry. Believe it or not, you do not have to do proofs when you take your SAT exam.
Really?
You won't have to do proofs ever again unless you become a math teacher. Seriously. I don't even know of any math you would take in college where you'd have to do proofs. They just teach it to you because they're trying to teach you deductive reasoning, basically. But I think it's just they're demoralizing everybody. So here we have two parallel lines with a transversal. Now, let me simplify this for you. By that, I give this talk to everybody when we get to parallel lines and transversals. That's another way, one that they go to great depths to make it more complex than it needs to be. Okay, here's my two parallel lines. Those double arrows, that's what it means. Okay, and there's the transversal. And what happens is you create 8 angles when you put that transversal there. Secret is you really only create 2 different angles. You create 1 and 2. And one of them's obtuse and the other one's acute, right? And to figure out which other angles are equal to either 1 or 2, you just look and see which one's obtuse, which one's acute. Well, what's 3 equal to?
2.
What's 7 equal to?
6.
Okay, but it's if I said make it equal to either 1 or 2. You're correct, it's equal to 6. But what else? Which one?
2.
Yes, exactly. In other words, 2 is an acute angle, 7's acute, therefore they're equal. In other words, you don't create 8 different angles here, you create 2 different angles. And they have a particular property where they're always supplementary with one another. In other words, 1 and 2 add to 180. So I'm going to be able to say 1 plus 2 equals 180. That's the secret to parallel lines and transversals. Now, I know how they teach it, and how they teach it has some value when you can't tell whether the angles are acute or obtuse. They teach you about alternate interior angles, right? They teach you, and they say those are equal. That's a theorem in geometry. They also teach you about alternate exterior angles. Those are equal. That's another theorem in geometry. They teach you about corresponding angles. 5 is a corresponding angle with 1. Therefore, they're equal. And they teach you about adjacent angles. No matter which 2 angles you look at, if they are side by side, either horizontally or vertically, they are supplementary. In other words, 1 plus 2 is supplementary, 2 plus 4 is supplementary, 6 and 8 are supplementary, 5 and 6 are supplementary. So the reason they get that complicated is precisely in case you have, and you don't ever see this on the tests, but you might. If I have this situation, and I don't know if it's perpendicular or not. They don't tell me it's perpendicular. In other words, this angle might be 89 and this one might be 91.
Mm-hmm.
So in this case, I cannot look at all the other 6 angles and figure out which one is acute and which one is obtuse. I kind of have to know those other theorems. In other words, first of all, I know that's got to be 89, right?
Mm-hmm.
Because it's vertical with the other 89. That has to be 91 for the same reason. And now when I get down to here, just treat it the same. In other words, it's 89, 91, 91, 89, I'm done. So even when the line is indiscernible from a perpendicular line, you can still figure it out. You don't have to use the acute and obtuse method necessarily. Okay, let's apply this. We're almost out of time, but we got a few minutes here. So what can I say? What equation can I write for the upper left one?
6x plus 12 plus 4x plus 18 equals 180.
I'm going to let you solve that on your own. I know you know how to solve it. Now give me the equation for that one.
Oh, for the next one? Okay. 6x plus 12 plus 54 equals 180.
And the lower left.
2x minus 5 plus x plus 25 equals 180.
And finally, the lower right.
2x plus 125 plus x equals, would that be 180 or 360? Because isn't it 360 because it's a...
We have to fill in some additional information on this one.
Okay.
That's a right angle. Okay. So what's this angle here? We're dealing with a right triangle. The two acute angles are complementary. So what does this have to be over here?
X.
90 minus x.
Okay.
In other words, this angle right here is, 90 minus 2x.
Okay.
In other words, whatever x is, this angle is complementary with it. So 2x plus this angle equals 90. And you'll notice that if you add these two things together, that's what you'll get, is the x's will cancel and you'll equal 90. So that's the way to write it when you know that it's complementary. Okay? What is this angle right here equal to?
X minus 125.
Well, this angle, whatever it is supplementary with the sum of the other two, correct?
Yes.
So that actually makes it 180 minus 125 minus x. What I'm really doing is the same as I do in the lower triangle, only it's 180 minus the sum of the other two angles, where the other two angles are that, and then when I remove the parentheses, I get that. Okay?
Okay.
Now you have all four angles. Now, this one's 90 here. So what do I know the sum of the four angles of any quadrilateral are equal to what?
360.
Okay, so let's start on the lower left and work our way clockwise. So, and then I'll let you go. 2x plus 90 plus this complicated thing here, which is 180 minus 125 minus x, plus 125 plus x plus this complicated thing, 90 minus 2x. All of that has to equal 360. And now, again, we have a equation with only one variable, I know you know how to solve that.
Yes.
And once you have x, that's all they ask for you to solve. And that might not even be the shortest way to do it, but that's the way I always know works, even though you end up having to add 1, 2, 3, 4, 5, 6 different angles together to equal 360, but still works.
Mm-hmm.
Okay?
Okay.
Hannah?
Yes.
Nice working with you. And if you make another appointment, the next time I will merely text you the meeting ID. I won't call you.
Okay, perfect.
Since you have the software now on that computer, is all you're going to need to do is always put in a 9-digit number, and it changes every time. So every time I have a session, it changes.
Okay, perfect. Thank you.
You're welcome. Bye.
Bye.
Whoops, hold on a second. You still there?
Yeah.
Was our session for an hour? It was for an hour, wasn't it?
Yeah, I think it was. I'm not sure. My mom.
Yeah, no, you're right. I was just thinking that I'm not supposed to have that much time before my next session. Yeah, I'm sorry. I do also do half-hour sessions. So, yeah, I don't usually get confused about it. I did this time. All right, should we just keep going through some of these?
Yeah, let's go. Should we go to the next page?
Yeah.
Okay.
Okay, that was the second page. We're going to go to this third page here. Yeah, okay, cool. And again, I need to download it. Okay. Well, gosh, I'm glad I caught myself before you hung up. Zoom a little bit more on that. There we go. And take a picture of it. What's collinear mean?
I'm not sure.
They're along the same line. They all are on a straight line.
Okay.
Okay. Linear means straight line. So collinear means all of these points are on that line at the base. Okay. There's no broken parts there. That is a straight line. FC is perpendicular, or excuse me, parallel to ED. So here, let's start writing on here. I'm just going to use a single arrow to indicate perpendicular or parallelness like that.
Okay.
And BE is perpendicular to ED. They already show that, so I don't need to do anything about that. And the measures of FAB are as marked. So they want to know what the measurement of angle FCB is, the one with the question mark in it.
Okay.
Okay. And like most geometry problems, you can't solve it immediately.
Mm-hmm.
You have to solve for other stuff first, and then you'll be able to solve for it.
Okay.
Okay. So what's the best angle to solve for first?
FAB.
No, that's given. That's 63 degrees.
Oh, okay. So what you solve for F?
How about EBC?
Okay.
This one right here. Only because we can solve for it. In other words, if you don't know where to begin, look for stuff that you can solve for. I know how to solve for that angle. What is it?
90 degrees.
Oh, it's a linear pair with 147. What does that mean?
So the other side's 147?
No, they're supplementary. In other words, here's what I'm looking at. This one's 147. This one has to be 33. They have to be supplementary. The magic number in geometry is 180. Get used to subtracting from 180 because you're always doing that in geometry.
Okay.
As you probably have figured out already. Right? I mean, everything is subtracting from 180. Not everything, but an awful lot. Okay, so that's 33. And now let's look at triangle on the right, EBD. By solving for that little angle there, I can solve for D. What is D now?
Sorry. 57.
Yeah, in other words, they are complementary. The two acute angles of a right triangle are always complementary, meaning they add to 90. Okay, now I can solve for this angle based on what?
The 33.
Based on the two parallel lines. Notice that this is what they always do to you, is they don't ever make the parallel lines simple parallel lines with a transversal. They complicate it by making all of these extra lines in here. But let's draw it just the two parallel lines and just the transversal. If this angle is 57, then what is, I don't even have to solve for this one. I'm sorry, I made a mistake there. I'm not solving for that angle.
You're fine.
Solving for the angle they want. Right? In other words, if that's 57, what's this one right here? Which is what they're asking for.
Okay.
What is it?
57.
Yeah. They are corresponding angles with respect to those two parallel lines. So I now can do that one directly, and it's 57. So in this problem, I actually had to solve for two other angles before I could solve for the one that I needed to solve for. And
okay.
That's very common. Get used to that because you'll be doing that a lot, especially with these figures I'm looking at here. Let me expand this just another measure so that I can write in without writing so tiny. There. Perfect. Move it up here. Get that zoom bar off there. Take a screenshot of it. All right. Now let's label everything they've given us. QRS is 50. Oh, that's already labeled. SPT is 62. That's labeled. PQ is equal to PT. That's indicated by the hash marks. Okay?
Mm-hmm.
Angle they want is TQR. This one right here. We'll call it X.
Okay.
Let's solve for that angle. Now, this is very interesting. This is a tough problem. Oh, it's a parallelogram. I forgot that. QRS. No wonder it was going to be hard for me to solve. PQRS is a parallelogram. So that is parallel to that. And that is parallel to this. Now, notice that one of my sets of parallel lines, I use the single arrows, and the other, I use double arrows, just so you keep clear about what's parallel to what. Okay. So we're looking for this angle here. We clearly can't solve that yet. We're going to have to solve for some other angles. Well, what's this angle down here that's right above the S? Here, let me point to it with my mouse. What's that angle right there?
50?
Does it look 50?
Oh, no.
Okay, if it doesn't
Oh,
look
so that's
50,
where we do,
then it's got to be supplementary, right? So
yeah.
it's either 50 or 130. Well, look at this angle. That's 50. That's an acute angle. That's a big obtuse angle, so that's got to be 130.
Okay.
Okay. Now, what else can we figure out? This is an optical illusion because the way they've drawn it, PQ is not the same length as PT, but that's an isosceles triangle. So I know whatever this angle is here, y, that has to be y also, correct?
Mm-hmm.
Now look at that triangle PQT. What can you say about, hold on, I screwed this up. Hold on a second. Nope, can't solve for that yet. Well, what can I say about this angle right here that I'm pointing at? Sometimes you can take the long way around here and you still solve it. You might do more steps than is necessary, but on some of these, the solution doesn't pop right out into my head. And when that's true, I just start solving for what I can solve for. Well,
Okay.
I can't put a number on that, but I know that that's a quadrilateral. So the four angles have to solve to 360, have to add to 360. So I can say that this angle number one here, angle number one has to be 360 minus x minus 50 minus 130. You see how I can make that statement?
Yes.
Okay. And if I simplify that, I get 180 minus x. I should have known that anyway. I didn't have to do that the hard way. The reason is there's a theorem for parallelograms. That means this angle over here is 50, right? In other words, you see the parallelogram is PQRS?
Mm-hmm.
Well, the opposite angles of a parallelogram are equal. So I can say that's 50. Now I can figure out why.
Okay.
Because I have an isosceles triangle here. Let's erase this over here. I didn't need to do all of this complicated stuff over here. I don't need to solve for that angle yet. And that's because now if you look at triangle PQT, what can you say? Give me an equation for PQT.
Y equals,
Not y. All of three angles are equal to what?
180.
Okay. And the reason y is equal to y is because that's an isosceles triangle and opposite angles are equal to one another. So that's why I know both of those are y. And I now know that that is 112. Again, not the way they've drawn it, but it is. In other words, you got to be careful looking at these things as if they're drawn to scale. They aren't always drawn to scale. In other words, that certainly doesn't look like an obtuse angle, but it is. Okay, so I can say 112, 50 plus 62, plus 2y is equal to 180, which makes 2y equal to 68, which makes y equal to 34. Now, I know both of those y's are 34. And let's see, that should be the last step we need, I think. No, maybe not. I still can't solve for x yet. Yes, I can. What does that angle have to be?
I don't know, equal to.
Look at the parallelogram. In other words, a lot of times the secret to these problems is being able to see one shape and eliminate all the other lines.
It has to equal to 130.
Right. So 34 plus x has to equal 130, correct?
Mm-hmm.
Which makes x equal to 96. So that finally, after solving for, how many other angles did we have to solve for? We had to solve for this one, that one, and that one. We had to solve for 4 other angles before we could solve for the one that we were trying to solve for. And that's very typical. And sometimes you don't necessarily see the pattern. And like I said, when I find a problem where I don't know exactly the pattern, then I just start solving for what I can solve for until I've solved all the angles. And then eventually you figure out how to solve for the angle you're trying to solve for.
Yeah, that one's complicated. You really have to see the separate shapes.
Yes, and that is one of the secrets of geometry, is being able to separate and see that parallelogram and the isosceles triangle. And notice they really didn't draw that to scale. PT is not the same length as PQ if you were to measure it. And that's why that angle came out to be 50-something degrees, making it look like it was an obtuse angle, even though it's clearly an acute angle on their drawing. All right, this one should be a little easier. Again, they ask for we have 2 variables. Okay? The hash mark through both of those means I can say what?
They're perpendicular.
Equal. When you see a hash mark in a triangle, it means every other side that has a single hash mark is equal. So I can say 6x minus 4 is equal to 3x plus 4y. Unfortunately, I can't solve it from that. Again, I have 2 variables and only 1 equation. So I got to find another equation. Well, based on that statement, give me the second equation.
51 equals 6x minus 4.
It's the perimeter. In other words, 51 is the sum of the 3 sides. So it's not 6x minus 4, it's 6x minus 4 plus 3x plus 4y plus 11. In other words, there's one side, there's a second side, and there's the third side. All of them have to equal 51. That's what perimeter means.
Okay.
Okay. And notice again, I have a second equation that's got 2 variables. So I couldn't solve it on its own. But if I treat it as a system of equations, I can solve it. Well, let's start by simplifying. Simplify that equation.
51.
Get it in standard format. Because you've probably figured out in algebra that when you have a system of equations in standard format and you use elimination, that's the easiest way to solve equations. Simultaneous equations. So if I put this thing in standard format, I want to put the x and the y on the left side and the number on the right side. What does that give me?
6x minus 4 plus 3x plus 4y plus 11.
Okay, let me back up here. I wasn't terribly clear here. Let's simplify that first by combining like terms. In other words, that 3x will combine with the 6x. If I subtract 3x from both sides, I'm left with 3x, right?
Mm-hmm.
Now, if I subtract 4y from both sides, I'm left with that. And I put the only number on the other side. So that's what that equation in standard format looks like. Now, let's put this one in standard format. This one, if I combine the x's, I got 9x. I've only got plus 4y. And everything else goes on the other side. So that 4 makes that 55. I got 15, and I got 11 that I got to subtract, so that becomes 44. So unless I did my math wrong, I think that's what that, I had to do my math wrong. Yeah, I did do my math wrong. Let's see, when I combine my x's, I get 9x, I got a plus 4y, but I got to subtract 11 from 55, and I got to add 4. So it's 44 plus 4, or 48. Okay? Now, that's in standard format also. So let's combine it with the other one, put them below one another, like that. Now, how do you solve these two equations that are both in standard format? Are you going to use substitution or elimination?
Elimination.
Why?
Because you have the x's and y's lined up.
Yeah, and I don't have to do anything to either equation, as all I got to do is add these things. And when I add them, one of the variables, the y variable, is going to disappear or get eliminated. Okay, so this becomes 12x plus 0 equals, got to add the right side, 52. So I got 12x equals 52. So x equals 4 1/3. Unless I did my math wrong. I'm still thinking I might have done my math wrong over here. Why did I cross that 4 out? Let's see, if I add that 4, was it 55? I added that 4 already. In other words, the perimeter was 51. It wasn't 55. So my final answer was 44. So that's 44. That totals 48. And if that's 48, then x is precisely 4.
Okay.
Okay. Once you've solved for x, how do I solve for y?
You plug it in.
To which equation? I got a bunch of them on.
3 times the 3x plus 4y.
How about plugging it into this one? In other words, I don't want to plug it into here necessarily. That's not simplified. But that's simplified to this. These, where I got the arrows connected, are the same. It's all the one that has the SF next to it is the simplified version of the 6x minus 4 equals 3x plus 4y. In other words, when I simplify that, I get this one here.
Okay, so we just plug it in.
Plug the x into that one and solve for y. So you get 3 times 4 minus 4y equals 4. Now you can do the algebra on that, right?
Okay.
What's the next line?
You'd add 12 to 4.
You subtract 12 from 4.
Oh, sorry.
So you have minus 4y on the left. 4 minus 12 is minus 8. Y is equal to plus 2.
Okay.
So x equals 4, y equals 2, and you've solved this problem. And that's really the only way to do it, is they give you enough information that you can come up with these two equations and two variables on your own, and then you have to solve them. Now, I could have taken a different tactic for solving this. I didn't have to put it in standard format. I could have solved each one for y and then let one side equal to the other side, solve for x that way. So there's a lot of times there's multiple ways to go here. Let's see if we can get this last one done before our time goes down here. These always intimidate people, but they should not. The reason they should not is because whenever you see the word flagpole, they're talking about a triangle.
Okay.
That's the flagpole. And the reason it's not a hard problem is because flagpoles are always at right angles with the ground. So we know it's a right
90
triangle.
degree.
Well, it's a right triangle. Right triangles are special. Okay? He installed his 30-foot flagpole. That tells us that side is 30. Erase that. That. Okay. He added a wire with one end attached to the top of the pole and the other end attached to the ground, which was 10 feet from the base of the pole. That means that's 10. That hypotenuse of that triangle is the wire.
Okay.
With me? There's a stake right there. It's in the ground. He's keeping his flagpole stable so it doesn't bend back and forth. How long was the wire? What is x?
Okay.
What theorem do you have to use here?
What's it called? The
Pythagorean Theorem.
That's it.
It's the most important theorem in all of geometry. You will not learn a more important one.
Okay.
You have to use frequently. When I said you don't have to do proofs on SATs, I was right, but you have to do right triangles galore. Tons of them. So what equation applies here? What's the Pythagorean theorem say? If I have a right triangle, and one side is A and the other side is B and the hypotenuse is C, then what the theorem says is that A squared plus B squared equals C squared. That's it in a nutshell, applying to right triangles only. It's not true with other non-right triangles, but right triangles, the sum of the squares of the two short side is equal to the square of the hypotenuse. So give me an equation that tells me that over here in our flagpole.
30 squared plus 10 squared equals x squared.
That's 900 plus 100 equals x squared. Makes x squared equal to 1,000, which makes x equal to...
Hold on.
Good. You didn't do what most people would have done, which would have been to set 100. It's not. It's the square root of 1,000. What's the square?
Okay, so 31.6.
Yeah. And now, let's look at that picture. If that's 31.6, that makes sense. The hypotenuse has to be the longest side of a triangle.
Mhm.
but not so long that it would be 100. In other words, if you looked at that problem and guessed 100, that's too long. The hypotenuse is not going to be 100 if the base is only 10 and the height is only 30. It not
Mhm.
only has to match the Pythagorean theorem, in other words, that has to be true. 31.6 squared is going to equal 10 squared plus 30 squared. But it has to be somewhat reasonable. If you came up with an answer of 100, that would not be reasonable relative to these two numbers. And it might just take you working with a bunch of right triangles to know what's reasonable and what isn't. You don't need to know reasonableness to come up with that answer. As long as you follow solving that equation and take the square root of 1,000, you'll be fine. It's that when people try to do this in their head, a lot of people would come up with 100.
Okay.
And it's not. It's 31.6.
Mhm.
Okay?
Perfect.
All right.
Well, thank you very much.
You are welcome. And whenever you need help, I'm available. Your mom knows how to make an online appointment.
Yes.
Or
Have a.
you know maybe. I don't know who made this one, whether it was your mom or you,
Oh
Hannah.
yeah, my mom.
Okay. Usually that's what happens. So she knows how to do it. And I will talk to you next time.
All right. Have a good rest of your evening.
You too. Thank you.